It has been shown that visual experience is essential for the spatial development in early life. Congenitally blind infants are not only deprived of the visual input, but also of the visual influences on the intact senses on their integration. Multisensory integration is the ability to use multiple sensory inputs at the same time. It is crucial to many developmental aspects such as body perception, manipulation, interaction, and coordination. The important role that vision plays in the early development of multisensory spatial perception raises the possibility that impairments in spatial perception are at the heart of the wide range of difficulties that visually impaired infants show across spatial, motor, and social domains. But investigations of the early development are needed to clarify how visually impaired infants' intact spatial senses, such as hearing and touch, support their emerging ability to make sense of their body and the outside world. We compared the sighted and severely visually impaired infants' responses to audio, tactile, and audiotactile stimuli presented on their hands. Two audiotactile devices were positioned in the two hands of the infant. In particular, we analyzed orienting responses of the eyes and the head of the infant after the stimulation. Reaction times were also calculated. Audio and tactile stimuli alone were important to understand the ability to localize a single modality. Audiotactile coherent conditions were important to understand the benefit provided by multiple stimuli. Audiotactile incongruent conditions were important to understand the sensory attraction when conflictual stimuli were provided. All the conditions were replicated with hand crossed to evaluate the influence of typical layout in external space on stimulus localization. The accuracy and the speed of localization in severely visually impaired infants for audio and tactile stimuli presented alone were similar to that of sighted infants, suggesting no need of visual calibration for this task. Severely visually impaired infants were able to show faster and more accurate localization of tactile stimuli on the hands than their sighted peers when the hands were crossed. Moreover, multisensory gain was evident in multisensory congruent condition for both groups, even if it was stronger in the sighted group. Multisensory gain was also evident with hand crossed. This suggests that both sighted and severely visually impaired infants speed their performance in multisensory congruent conditions. In multisensory incongruent conditions, when sound and touch were provided in conflict, blind infants orient preferentially to touch and sighted infants to sound, and the same was true for the crossed position. These results suggest that severely visually impaired infants compared to their sighted peers show faster and more accurate localization of touch with hand crossed, and these results suggest that they have a preference on anatomical location of touch and neglect the canonical layout of the body. They also show a reduced audiotactile spatial gain in response speed, and this suggests attenuated spatial integration. Finally, they show greater weight given to the tactile condition in audiotactile conflicts, suggesting that they gave more weight to anatomical features. To conclude, these results suggest that there is an early influence of visual deprivation on sensory development. Severely visually impaired infants represent space in a different manner. These results suggest that may be a potential cascading influences of visual deprivation on sensory development behind vision, and in particular in audio and tactile processing.